Ever wondered how your GPS finds the shortest route, or how your Facebook friend suggestions pop up? Welcome to the world of graphs. We're back in the coded universe where the complexities of programming are unraveled with everyday examples. Today, we'll explore graphs, a fundamental structure in programming that has a profound impact on various real-life applications, from traffic navigation to social networking. So buckle up as we traverse the exciting terrain of graphs and programming. A simple way to understand graphs is by visualizing a road map. Picture a map with a series of cities, each connected by roads. Now, in the world of programming, we give these cities and roads some fancy names. The cities become what we call vertices, or nodes. These vertices are essentially points in the graph. Now let's look at the roads. In a graph, the roads that connect the cities or vertices are known as edges. So, in our roadmap analogy, every road that connects one city to another represents an edge in the graph. This might sound like we're just playing a game of renaming things, but these terms, vertices and edges, are the building blocks of a graph. And it's not just road maps. Think of a network of friends where every person is a vertex and each friendship is an edge. Or consider a web of computers where each device is a vertex, and the connections between them are the edges. Now, let's take a step further. You might be wondering, how do we represent a graph? Well, there are many ways, but two of the most common methods are adjacency matrix and adjacency list. An adjacency matrix is a square matrix used to represent a finite graph. The elements of the matrix indicate whether pairs of vertices are adjacent or not in the graph. On the other hand, an adjacency list represents a graph as an array of linked lists. But whether it's a matrix or a list, the purpose is the same: to depict the relationships between vertices. That's the beauty of graphs. They encapsulate relationships, whether it's between cities, friends, computers, or even abstract concepts. So, in essence, a graph is a set of vertices and the edges that connect them. It's a way of representing relationships, connections, and networks. And that's what makes them so powerful and versatile, not just in programming, but in many areas of life and work. Now, you might be wondering, where do we see graphs in our daily lives? Well, think about the internet. It's a colossal graph. Each website represents a vertex, and the links that connect these websites are the edges. It's through these connections that we surf the web, hopping from one vertex to another. Consider even the way we interact socially. Platforms like Facebook or LinkedIn are essentially graphs, where each user is a vertex and every friend or connection forms an edge. The vast web of connections we navigate daily in the virtual world is a graph. Let's not forget about family trees. They are a special kind of graph known as a tree graph. Each person in the family tree is a vertex, and the familial relationships between them form the edges. From your great-great-grandparents down to you, the family tree graphically represents the lineage and relationships. And it's not just these. Roadmaps, organizational structures, even the ecosystem, all can be represented as graphs. The vertices could be cities, employees, or species, and the edges could symbolize roads, hierarchies, or food chains. These illustrations show how pervasive and fundamental graphs are in organizing and representing complex structures. So, the next time you're browsing the internet or looking at your family tree, remember, you're interacting with a graph. Graphs have certain characteristics that make them incredibly versatile. Like the many roads and routes we traverse daily, graphs can be directed or undirected. Think of directed graphs as one-way streets where movement is allowed in just one direction. These are particularly useful when we're dealing with situations where the relationship between points isn't reciprocal. For instance, if you're sending an email, it's a one-way communication unless the recipient decides to reply. On the other hand, undirected graphs are like two-way roads. Here, the relationship between the points or vertices goes both ways, much like a good conversation between friends where information flows in both directions. But that's not all. Graphs can also help us find the shortest path between 2 points. Imagine you're in a maze and trying to find the quickest way out. Or perhaps you're trying to find the fastest route to your friend's house in a bustling city. That's where the shortest path comes in. Lastly, graphs can also show us the most robust network, or the most reliable path with multiple connections. This is akin to having multiple ways to reach your destination just in case one road is closed. These characteristics allow graphs to model a variety of real-world situations efficiently. Whether it's navigating through a city, sending an email, or even planning a party, graphs have got you covered. The power of graphs lies in their wide range of applications. They are the secret sauce in many fields, particularly in programming. Let's take a peek at a few examples. Imagine you're a delivery firm, trying to find the most efficient route to deliver packages across multiple cities. A daunting task, isn't it? But with graphs, it becomes much easier. By treating cities as vertices and roads as edges, you can use algorithms to find the shortest or most efficient path. And it's not just about physical travel. In the virtual world of social media, graphs are equally vital. Consider each user as a vertex and their connections as edges. Now you can analyze these graph structures to understand patterns, trends, and even predict future interactions. So from planning routes to understanding social networks, graphs are invaluable in solving complex problems. That brings us to the end of our journey through the world of graphs. We've navigated vertices and edges, seen how graphs are omnipresent from the internet to our family trees, and how they're powerful tools for solving real-world problems. If this piqued your curiosity, don't forget to hit the like button, drop your insights in the comments, and subscribe to Coded Universe for more programming decoded. Remember, the world is a vast graph waiting to be explored, so keep coding.